Hello everyone, welcome to EFS. This is project number 4, and in this project we're going to create an LED display through which whenever we send some text from our mobile app, it's going to display over. As you can see, I'm already entering a text, and once I click on send, you can see the text is being displayed. And this text keeps on rotating until we send a new message. Okay, as you can see, now it's going to go for a second rotation, second scrolling, not rotation to be, yeah, it's called scrolling. So here we have went to the second scrolling, and along with that we have added special designs. Now I'm gonna send something called arrow right. Okay, so whenever I send an arrow right, the design which we have kept coded in the device is gonna show up something like this. Okay, so along with that, even after this, if you send a message again, it's gonna start scrolling. So here you can see I'm sending just a simple hello, and boom, it's working. Okay, so before getting into the code, let's just understand how an actual LED display works. So for the demonstration purpose, let's create a 2x2 LED display. So for a 2x2 LED display, we will be requiring 2 LEDs. Okay, so let's just consider this as an LED which has an anode and the cathode. The longer one is the anode and the shorter one is the cathode. Okay, so now what we're gonna do is we're just gonna wait a second. I'm gonna create 4 more copies of this. So this and then this. Okay, now how the connection usually happens in any kind of LED displays is that the anodes are connected together. Okay, for example, the first and the second LED anodes, the positive signals, are connected together forming row 1. So let's name this row 1. Okay, and you must have guessed it already. So the second set of LEDs will be named as row 2. Okay, and then the cathodes, which is this, are connected. The first and the third LEDs cathodes, the negative, are connected together to form call 2, call 1, which is column 1, and similarly this, again I'm going to take this and this, are joined together to form call 2. Okay, so how this actually works, say if I want to lit only the first LED, then at that point I'll be supplying a 5-volt signal to row, since this is an anode, and I will be supplying a 0 signal or the ground signal to the column 1. At that point only this LED will be lit, because even the second LED has the 5-volt signal, it doesn't have a ground signal. So as we know in electronics, for any component to work, you would require a 5-volt signal and a ground signal. So since the column to the second LED does not receive a ground signal, it does not lit up. Okay, now the question may arise, what if I want to switch on 1 and 4? Okay, so here a key concept plays in role called the persistence of vision. Okay, so what actually happens is that we are gonna supply a signal over here, 5-volt signal, and a high volt signal here the ground signal as well. Here we're gonna set the signal to low, and here we're gonna set the signal to high using the 4 Arduino pins. So what generally happens is that this LED is gonna lit up, and after that what we're gonna do is that we're gonna set this column as low, and then we're gonna set this column as high, and then we're gonna set this column as high and this as low. Then this LED would lit up. So in general, what happens is that this happens so fast, like the LEDs are getting turned on and off so fast that the eye thinks that both of these LEDs are switched on. So this effect is called persistence of vision. Okay, so in reality, the LEDs are getting switched on and off in an interval of milliseconds, which our eyes cannot catch. So for a naked eye, it feels like this both LEDs are switched on. So that's how we control an LEDs. Like if we want to control a different set of LEDs, that's how we do it. But as you can see here, we are utilizing 4 distributors. We just cannot connect these 2 pins to ground because we need to make them high and low. So if we connect directly to a ground pin, we cannot do that. So we need to connect them to an Arduino pins as well. So as you can see here, we require 4 digital pins, and this is just a 4x4 display. And now if you say we have 8x8 display, then you'll be requiring 16 pins, right? So to avoid this, we will be using an IC called MAX7219, which is a driver IC. Okay, so the driver IC kind of behaves, I mean, it does multiplexing all by itself. So the MAX7219 works on an SPI. Okay, let's say SPI is a serial peripheral interface. Okay, so the MAX7219 IC works on that. So let's just check the diagram. Okay, you can see here, right? So this is the MAX721 IC. So this outputs, okay, this IC controls this entire LED board by using an SPI protocol. Okay, so the SPI protocol, like it's a master slave protocol, you can just read it somewhere in the internet. So in short, we are gonna use only 3 pins of the Arduino, and we're gonna control, send signals to switch on which set of LEDs and switch off which set of LEDs. Okay, and the MAX7219 IC will do that for us. Okay, so as you can see here, I have connected the 3rd pin to the clock, the 11th pin to the D in, and the 10th pin to the chip select. Okay, so as you can see, we have used only 3 pins, specifically 13, 11, and 10, because as per Arduino Uno schematic or the Atmega 328P, which is the microcontroller we are using on Arduino Uno, as per its schematic, the 13 pin is the clock pin, the 11th pin is the D in pin, which is generally MOSI or master and sale, those kind of pins, and the 10th pin is also is a chip select pin as per the schematic. Okay, so if you are using a different set of board, it will be having a different set of pins. Like if you use a Mega, it would be having a completely different set of pins. So make sure if you're changing, if you're using Arduino Uno, this schematic works. If you're not using Arduino Uno, you have to check the schematic of that specific microcontroller and see which pins are the SPI pins. Okay, and as per the schematic, it's pretty simple. As you can see, the ground is, both of the grounds needs to be connected, and a 5-volt signal which is connected to the VCC pin. And here we are just using a TX to RX connection. Okay, because we don't need any kind of acknowledgement from the Arduino, so we are not connecting RX and TX. Okay, so the connection is pretty much simple. And one more thing, guys, I need to say that I would not be showing in this video the NodeMCU code and as well as the app code, because the NodeMCU code and the app code is similar. It's not similar, like it's completely the same as we have used in the LCD display. Okay, so that's the 3rd project. So the code and the code explanation and the NodeMCU's code explanation and the app code explanation is done in the previous video. So I'm gonna comment the link of the previous video in the comment section itself. Okay, so now let's just start with the coding part. So moving to the coding part, so here I have already opened an empty Arduino IDE file. So here we would be requiring 3 libraries. The first is SPI, which is already an inbuilt library. The other 2 libraries we need to download it. For that, we'll be going over here and searching Parole, P-A-R-O-L-A, Parole. So this is the library. So I have already installed this. Along with that, we'll be requiring another library. It's Max77, and after that it's generally 2, and then we will be having XX. So I'm just going to search it. So here you can see, right, Max72, this one, not this one. This is for the 7 segment display, which is like numbers. So this is for the 8x8 LED displays. Okay, so I have already installed those. So let's go into the code. So what I'm going to do is I'm going to include the library first, which is md parole, md underscore parole, 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 a.h. So this is to give us the scrolling effect for the LED display. Okay, and after that we will be including the max72 library. So this is the library that controls the max7219 IC that we are currently using. Okay, so also it can also control max72 series ICs as well. So here we are using 7219, so this will be controlling the 7219. So what 7219 does, so it kind of control the LED displays. Okay, so max 72xx.h. Okay, and then finally we will be including SPI, the Arduino's inbuilt library. Okay, so just go and check what SPI actually does. So it's like a communication protocol. So I'm gonna save this as this. Okay, okay, so we're just gonna compile to make sure that we haven't made any spelling mistakes in the library calling. Good, so there are no spelling mistakes. Fine. So now we will be defining some variables. So the first one would be hash define equals to hardware. So we're gonna define what kind of LED board we're actually using. So I'm using FC16. So you maybe use a different one. So depending on that, you have to change it. So hardware underscore type. Okay, which is MD underscore max 72xx. I think this should be capital. Yeah, capital. And then you have to define the board. My case is FC16, so I'm going to say FC16. No, FC16 underscore HW. Okay, that's my series. Okay, then after that we're going to define another variable. Okay, and I'm going to call it max. So the max 7211 devices. So like how many LED displays are we actually connecting? Okay, so as I've shown you in the video, we have a 4 displays. So I'm going to define them as 4. Okay, and here the next definition will be the pins, the SPI pins. Since we are using Arduino, so the SPI pins are kind of stagnant, like they are already prefixed. So in case of Arduino, the clock pin, which is CLK underscore, I'm gonna just say pin so that we would remember, is 13. And then we would be requiring a data pin, which I would be defining as data underscore pin. Okay, so I would set the pin as 11, and then okay, it's a dollar. Okay, and after that we have a control signal pin, and I'm not actually defining it. So it's kind of, there are already, like if you just go to Arduino schematics, you can see those SPI pins clearly. Since I'm using Arduino Uno, 13, 11 and 10 are those pins. If this is a different kind of Arduino board, you would be having a different set of pins. Okay, you have to kind of check with the schematics. Okay, so we have already defined all of those. So the next step would be defining the display properties. Okay, so the reason why we define all of those variables. Okay, so I'm gonna go MD. So I'm going to just copy this. So this is the class. Okay, if you just go see, this is the class, and now we are declaring, initializing this class with some properties, and those properties are the above one. So first we have to define the hardware type. So I'm just gonna say hardware type, comma, and then we have to define the data pin. Okay, comma, and then we have to define the clock pin. Okay, comma, and then CS pin, and finally the number of devices. You can directly give those pin numbers and all of this here itself, but for just for better understanding, I have given it like this so that we could understand, like, okay, this is the clock pin, this is the data pin, the clock pin is what goes over here. That's the reason I have given you like this. Okay, so then I'm gonna say the max devices. If I directly give the numbers, you'll be thinking 4 as the digital pin. So that's the reason I have defined each and every pin with a variable. Okay, and after that, so to hold the string, we need some buffer. As you know, Arduino doesn't support strings. So what I'm gonna do is I'm gonna declare a character. Okay, which I would say I would call it input character, and I would say it has a buffer size of 100. So instead of saying it like defining it inside, I'm gonna create another variable so that I can later, we are going to use this buffer size in different places. So I'm creating a variable for this, and I'm saying max characters of 100. Okay, so what does that actually mean? So this input character array can hold only up to 100 characters. That's it. You can increase it, it's up to you. Okay, and then finally an index. So I'm going to use a byte index. You can use an int as well, not a big deal. So I'm using byte for lower space. That's it. So since it's 100. Okay, so we're done with the declaration part. Now we're gonna go to the setup. Okay, so here we're gonna begin serial.begin. Again, you can use software serial as software serial library as well, but I'm preferred to use the hardware serial, and I'm gonna set the baud rate as 11,52,000 because we're gonna kind of type the name in the terminal itself and click on send, and it's going to be displaying on the board. So I'm using the hardware serial. Okay, later on we're going to connect with the NodeMCU. So after that, so we have to display, like we have given the display, right? So we have to initialize it. So for that, we're going to say my display. No, I thought I copied this one. My display dot begin. Okay, so it initializes the display. Okay, and then here we're gonna set the intensity in the sense brightness, like how much brightness does the LEDs actually have. So I'm gonna say set int. Yeah, we got it. Nice. So it ranges from 1 to 15. So 0 means complete off, 1 is the lowest value, while 15 is the highest. So I'm gonna set it in middle, which is 4. It's actually not middle, but I prefer to set it for 4. Okay, then we're going to initialize this display again. Not initializing, we're going to take this display, we're going to clear the display. Well, I mean, there is a great chance that there could be a data before time. So while it initializes, we are clearing the display so that we can get a fresh set of data. Okay, so after that, this is the main part. Okay, so here before printing itself, like printing with a serial, let's just print a normal data. Okay, so I have set up the camera. So before we write the serial part of the program, so let's just check whether display is working or not. So for that purpose, what we're going to do is that we're going to display some text. For that purpose, so I'm going to take my display dot, so display text, where is it? DISPLAYT display text. Okay, so we're gonna remove this. So yeah, it's kind of cool. So here we have to give the text. So I'm gonna say hello EFS. So position, like where the text should go. So most probably it's center, since we're gonna we're gonna keep the scrolling effect, so it doesn't really matter. So we're gonna just keep it as center. Now the speed, so here you have to define speed, which is around like 80. I'm gonna give it 80. And the pause, like after every scrolling, like how much pause it should take. So I don't want any pause, so I'm gonna give it pause. And then we have effect in, and we also have an option character called effect out. Okay, so since we want a scrolling effect, so I'm gonna say it as PA scroll underscore left. So this is the effect in, and after that there is an optional character which is not required, but I'm just gonna give it as scroll left only, which is the effect output. So there are many options, you can just play around with them. Okay, so I'm gonna upload the code. Hope there are no errors. Okay, we got an error. Oh, sorry, here we have to define double quote. Okay, so I'm gonna okay, we have a comma. Let's upload this code. It's compiling. It's yep. So there are no more mistakes, and we're done uploading. Cool. So my display text. Oh yeah, one more thing we have to define here. We have to tell the display to animate it, like this effects and all the displaying only happens if we animate it. So I'm gonna say my display dot display animate. Okay, so we need to make sure that it kind of loops again. So whenever my display animate is true, we have to make sure that the text inside it gets reset, like the looping, like the displaying gets resetted. For that purpose, we're gonna say my display dot reset, display reset. See here, so display reset, you can see here, reset the current animation to restart all zones. Okay, so this one kind of keeps them in the loop, and the text keeps on display until we don't pass on a new text. So now what we're going to do is, now we're going to upload the code. Okay, yeah, it's a column. So I have used the IP webcam, so I'm going to take it right now here. I hope you guys can see it. Hello EFS. So actually my cam is kind of a slow, but in reality, in real check, it's actually working pretty fine. It's going pretty fast. Like if I'm keeping my hand right now, but you can see it's coming later on. I have removed it. So the display is not slow. It's just the streaming is kind of slow due to my poor Wi-Fi network. Okay. So now let's move to the other part. Okay. So I'm gonna just remove this. I don't want anything to be displayed at the beginning. Upload the code. I think we have uploaded the code. Yep, we have uploaded. Now we're gonna write the serial section of the code. So here we're gonna do a while serial, a hardware serial dot available is, like, while serial dot available is greater than 0, like there is some kind of data inside it. Okay, then we're gonna read a char. We're gonna read one char at a time, or else you can do a string, like read string until, whatever is up to you, serial. So I'm gonna just read one char at a time. Enter. And after that we're gonna write a condition. Since we are kind of entering to a serial monitor, we can say that whenever there is a backslash n, you know, the new line code, so at that time we're gonna ask it to display the display the text on the LED screen. Else, first we're gonna write else condition. So whenever we receive a backslash n, that means that we have entered the text and then we clicked on enter, like it's going to the next line. For that purpose, like this is a stop signal. Okay, so for that purpose, what we're gonna for that reason, we're gonna first start with else. Okay, so in the else, what we're gonna do, we're gonna check if the index size is less than the buffer. Now do you understand why I kept I kept a variable for buffer size -1, since index is starting with what we call a 0, so it will be included as well. So since array starts with a 0, So -1 means the size is 100, but if we count from 0 to 99, the total number of digits are 100. Okay. So for that purpose now, and then we're going to take this input characters. Okay. We're going to say input characters of, now what we're going to do is take is the index. Okay. Index plus plus. So like for every new character, the index value kind of increments and each character is placed on each position. Okay. And finally we're gonna pass the str. Now what's gonna happen is that as long as it doesn't have the less than, like as long as it doesn't receive the backward slash and this specific character, it keeps on inputting each character into this array. Okay, input char array, as long as the size is less than 100, in this case is 99. Okay, after that we're gonna, so if at any point we reach 100, so we're gonna say input character chars. Okay, so here it is actually 98, since we are saying less than. The reason why we use 98 is because we're gonna introduce a new character which is a null. Okay, so after that we're gonna print it just to see what we have sent. So I would be saying input characters. Okay, and after that we're gonna clear the display, and then we're gonna use this. Now we are going to display the text. So what would be the text? That would be the input character. So whatever we have written in the we have written the serial monitor. So I'm going to just remove this and keep it over here. Okay, let's just compile the code. Let's see if you missed anything. I don't think we have missed anything. Okay, now we're just going to compile the code. Okay, we missed something. Input characters of index. What was it saying? Input characters was not declared in the scope. Of course I declared it. Oh, it's input char. Again, one more. Okay, input char. Some kind of motion depending on the compiling. Okay, why am I doing it again and again? Input char, anything else that we missed? I hope so we didn't. And we're done. Okay, so now let's just upload the code. I'm going to keep them side by side. Let's just say here, here, and then we're gonna take this one and keep it over here. I hope this is visible. Yep, that's my hand. It's kind of a slope, but never mind. Now we're gonna open this. We have already set the baud rate. I'm gonna type hello EFS and enter. I hope it's visible to you guys. Hello EFS. Okay, so let's try something else, like I will type Arduino Uno and see whether the old text is actually getting replaced or not. Okay, we are not able to replace the old text. We must have missed something. Input character. Oh, we forgot to set the index to 0. Now it's gonna overflow. Okay, so since it's the hello world is not 100 characters, that's the reason the hello EFS and Arduino Uno were combined. So now I'm gonna upload it one more time. Okay, now let's try hello world this time. Enter. I hope it's visible to you people. Just zoom in. Yep, we can do this. Hello world. And then we're gonna say Arduino Uno. This should replace right now. So let's just to be clear, everything is working fine. As I was showing you in the beginning of the video, it's just my streaming is kind of slow. So for that purpose, you're seeing that lag. Okay. So yeah, that's it. We're done. Okay, with this, we're done with the scrolling section. So now we can send anything we type in the serial monitor. It will kind of scroll in the display itself. And now once we connect the RX pin of the NodeMCU to the TX pin of the Arduino, so whatever we send it through our app, which we have already built in the previous video, that text would be displayed over here, as I have shown you in the beginning of the video. Okay, now let's say that if you want to show some kind of symbols, then what we're going to do, unfortunately, the this library, I don't know how to pronounce this, parola, I don't know, yeah, parola, this only supports numbers, alphabets, and some special characters, but it does not support what we call this kind of symbols like the arrow or the smiley face or a heart shape like that. For that purpose, if you want to display, we have to define them manually over here. So like if I want to display, say, a arrow, then I have to use the Max72XX library, and by using that I can kind of show the symbol, because I'm going to control LEDs using the LEDs are generally controlled using the Max72. So when we kind of define what LEDs to be lit by using a code of Max72, or the functions of the Max72, then we can create our own specialized symbols. Okay, so now we're going to do that. So for that purpose, let's just say I'm going to just take this. So we're going to use the Max72XX object. So that would be, just copy this Max72 object. Okay, and along with that, I'm going to call it MX. And then I'm gonna say here simply mx dot begin. Okay, so in the video I said that we can even use serial dot reach string. So here I'm gonna show you, like, we can use it, but we're gonna use it in a bit different way. So I'm gonna show you like how we're going to use it. Okay, so let's just do one thing. Let's take this part, copy it, and paste it over here for the time being. And while serial dot available, this is everything is fine. So I'm gonna remove this logic completely. We're not gonna be needing this kind of logic anymore. Okay, so first we're gonna take first we're gonna change this one to reach string until the new character. Okay, sorry, the next line. So at the back of slash n. Okay, so it's gonna read, and along with that we have to change this type to string. Okay, after that what we're gonna do is we're gonna take if str equals to, say, arrow right. Okay, then we have to write a function to show that specific symbol. Okay, for that we're gonna declare a new function. I would call it draw shape, since we are drawing a custom shapes. So you can even call it custom shape, but I'm going to call it draw shape. Okay, so for that so this draw shape will be accepting two parameters. The first one will be the device. Like, since we have 4 LED displays, we're gonna tell on which LED display the specific symbol needs to be shown. Okay, then we're gonna pass a byte array. So in this byte array, we shall declare what LEDs. For whenever, like, we have an 8x8 LED, right? So So it's around like 64 LEDs. So the byte also will have 64 zeros and ones, and there'll be a total 64 bytes, and whatever we'll set it as one, that specific LED will be on. I will show you in just a second. Let me just compare this. So I'm gonna say it has a 8 array, a size of 8, and then we're gonna go here. We're gonna write a for loop. We will say for int I equal to 0, and then let's call it column, since columns are the one that's being controlled. So since it's always 8, so I'm gonna simply say call less than 8, and then call plus plus. Okay, and after that we're gonna use the inbuilt function called set column. Okay, and then we're gonna pass the device. Okay, and after that the column, and inside, like, we are selecting the column. This is the first column, and inside that we're gonna take the shape, like we want the first columns, which LEDs are to be lit and which LEDs are not to be lit. So we're gonna pass the call here. Okay, so I've already created a byte array. It's kind of a difficult task, so I've already done that. So here you can see the byte array, right? Arrow of right, and here you can see B000. So if you can see, there are total of 8 characters. Okay, so 8 bytes. So whenever there is a 0, that specific row, for example, this is the first row, right? So the first row will be lit. The first row, the first LED will be off, the second LED will be off, the third LED will be off, and the fourth and fifth LED will be on. And then this kind of something similar to that. Okay, so these are a kind of columns. Okay, so after that, what we're gonna do is we're gonna call this function called draw shape. So I'm gonna take the first device only, so I'm gonna say 0. So 0 means the first device, and after that I'm gonna pass this arrow right. Okay, so what happens whenever we type arrow right in the serial monitor, it will not be going to the display, but it will stop. It will be passing to the draw shape, like this specific function will be executed. Okay, in the else section, what we're gonna write is this, but here we have to do a small thing because we'll have an error to be more precise. Let me just format this neatly. Okay, so we need to pass this one, right? But the problem is this function accepts. See, I'm just gonna compile this. You're gonna get an error, sorry. So here you can see, right, this function accepts an array of these items, like a character in a pointer state. So further, like in a, to be more precise, like in a character buffer state. Okay, so sorry, I mean character array state. So for that purpose, we need to convert this string into a character array. So we can do it by using the inbuilt function, that is str. So the string that we haven't taken to, okay, char array, CHARARRAY, char array, and then we're gonna pass the input chars, which we have already taken. Oh, the box size should be this one, right? Yep. So input char, comma, buffer size. And then we're gonna pass this over here. Okay, so now let's just compile this. So we got something here. Then mag mx dot set column. What happened? mx was not declared in this scope. Okay, this needs to be capital. This excess needs to be capital. Let's save it one more time. I hope. Okay, semicolon. Why do I miss a lot of semicolons? Strange. Okay, let's just upload this. So I'm gonna bring the camera one more time. So here's the camera. Here's my arm. Let's kind of minimize this to a small. Let's open the serial monitor and let's take the arrow right. We're gonna make this as small as possible. Yep, arrow right and enter. You can see, right? Arrow right. So like if you can see, the arrow kind of points towards this direction, but so more precise, like if you do this, then it will work more precisely. You can just adjust those bits, and however you adjust, it's gonna change. So if I kind of let this one, like if I make this one as 1, then you will see so now if I say arrow right, you'll see, you can see here, right, an extra LED. It's lit on. So here by this you can control each and every LEDs by just simply passing ones and zeros. Whatever LED you want to be switched on, you can make them as 1, and whatever LED you want to be switched off, you can make them as 0. Okay, and even at the same time you can even select the specific device. Since I have selected 0, it has taken the first one. If I set it as 1, now I'm gonna pass the message. See, it has switched it to the second display. Okay, so similarly we can test this out. Now say I want to write some message, hello world, and enter. See, the display got cleared and it's working as usual. Only for a specific set of characters it's gonna change. For any other characters it won't. Okay, everyone, I just found an issue, so let me show you what's going wrong. So as you can see, this is our Arduino code. I'm gonna open my serial monitor. I'm gonna send hello. It is scrolling. Now when I send arrow right, what we are actually expecting is the symbol of the arrow to be displayed on the second LED screen, but it doesn't happen because we have a small error. So let's fix that. So why is it happening? Because this function does not allow the draw shape to execute, because what happens is that the draw shape only executes once, but the display animation is overriding it. Okay, so what we need to is that we need to stop this display animation. Okay, so how we are going to do that? So we're going to declare a boolean. Okay, so I'm going to call it stop animation. Okay, so we're going to set it initially as false. Okay, so now I'm going to add the specific condition over here. So it would be like, if stop animation is false, only then you have to do the reset function. So I'm going to set this, and then what we're going to do, we're going to go over here and we're going to set the stop animation as true. Okay, because here we want the animation to stop, and in the else condition we're going to set the animation to false. Okay, this will make sure that we only display, like the arrow gets displayed and the scrolling effort completely stops. And whenever we send a message which is not arrow right, the stop animation should work. Okay, so along with that, so there is one more issue. Let me show you what's going to happen. So now, so it's uploading. Yep, it's uploaded. So now if I send hello, it will work. Okay. If I send arrow right, that will also work, but see what happens. You can see that ELLO, right? So we need to clear the display first. So for that purpose, we already know what to do. So all we need to do is copy this and paste it over here. So we're going to clear the display, and along with that, I'm going to just clear the input char as well, which we have it over here. So for that, we'll be using the Arduino's inbuilt function memset, which will clear the array, and also we need to pass the buffer size. Okay. Boom. Now we're going to re-upload it. It's uploading and we're done. Okay, let's go over here. Let's type a message. I'm going to call it hello world. Let's give it some space. Enter. You can see the hello world. Now I'm going to type arrow right. See, it happened. And now again, if I say hello EFS, it's gonna work. Okay. So with okay guys, we are done with our video. For this project, I'm not going to create a separate repository since the NodeMCU code and the app code is same as the LCD display. So I'm going to keep this code in the same repository of the LCD display. Okay. So along with that, I'm going to comment the link of the repository over there, and along with that I'm going to give you the previous videos link, like the LCD display where we have created the app and we have written the NodeMCU. I'm going to paste that link over here. Okay, I'll try to create timestamps for those videos as early as possible. Most probably you'll be having the timestamps in the description section of that specific LCD display video. Okay, so thank you for watching, and make sure if you have any doubts, leave them in the comment section. Okay, thank you for watching. Bye.